So hello, welcome to the first lesson in test of hypothesis. So firstly, we are going to test the population mean based on the information we get from the sample. So now we are going to test for the one sample mean, which means we have only one population. We have taken one sample and we are in fact testing or checking the mean value of the population based on the information of our sample. So later we are going to check for the population variance. So now we have a special case. This special case that when the variance of the population is known. So this sigma square, which is the variance of the population, is known, which now we are lucky to have. So this is a special case, and later we will see what will happen if the population variance is unknown. In fact, before doing any checking or testing for our hypothesis, we should choose the confidence level which we are going to test upon. So now suppose this is the normal distribution. The normal distribution is centered at the mean value, and the variance represents the width or the spread of the data around the mean value. So in fact, the confidence level represents the interval or the majority of the percentage of the data to be included in the population. So now suppose we have the standard normal distribution. We have the mean value to be 0, but in fact for the right side we have the data going until positive infinity, and to the left side we have data going until minus infinity. So in fact, the confidence level we are taking is to represent the majority of the data which is centered around. We know that, for example, if we take the confidence level to be 95%, in fact 95% is the most popular and famous confidence level to be taken in most hypothesis testing. So in fact 95% is the total area under the curve, which includes the majority of the data in this population. So this means we have 5% on both sides. For example, here we have 2.5%, here we have 2.5% also to the left. We are sacrificing by 5% of the data after some limits. In fact, we should have these limits because it is unlikely that large values belongs to this distribution. Also very small value, it is very unlikely that they belong to this distribution. So in fact we will call the 5% as alpha, and alpha will be also called the error value, because it is possible also that the values after the upper limit or below the lower limit also can be real values for the same population. So in fact there is a possibility to commit some kind of error like 5% if we take the confidence level to be 95%. So what will happen after that? This is an important point and important step in test of hypothesis, is to choose the test statistic. So now we know the sigma square of the population or the variance of the population. Now we are testing for a specific mean for the population, and we have estimated the sample mean. So always we have the test statistic as this equation. We should compute the difference between the estimated value and the hypothesized value. And after that we should divide by the standard deviation of our statistic. So now we have this value which is called Z0. We have Z0 which is equal to, we have X bar which is the sample mean minus the mu which is the hypothesized population mean. Now we divide by sigma over square root of n. In fact sigma over square root of n is the standard deviation of X bar itself. We know sigma, we are lucky to know sigma of the population, also we divide by square root of n to have the standard deviation of x bar. So now z0 is the test statistic, which will be calculated and used after that to check or examine our hypothesis. We know that x bar is the sample mean. We know that mu is the hypothesized population mean. Sigma, we are lucky in this case that we know sigma, which is the population standard deviation. And we have n, which is number of elements inside the sample or the sample size. Okay, so let's have a real example. We have seen these bottles or water bottles and the capacity. In fact, we assume, for example, this production line which produce an infinite number of water bottles. So randomly, at random time and random manner, we are going to choose some elements of these bottles. So we have taken, for example, 9 bottles at random. This will be in fact our sample. After that, we decide our property that we are checking. Here we are checking the property of the capacity. So we have measured the capacity of the 9 bottles. We had some capacities above 500, for example 502, and we had some capacities below 500 like 499. And all these values are the capacities of the 9 element or 9 bottles inside our sample. So this is our hypothesis. We have an assumption, which is the null hypothesis. Our assumption is that the mean value of the water bottle capacity is 500 milliliter. So we are afraid or worried that the mean value have changed to be not equal to 500. This is our alternative hypothesis. So now also our information, we have the sigma square or the variance. Suppose we know the variance of the population to be 4. This is known in our case. We have the sample size or number of elements, which is 9. And now let's choose 95% confidence level, which is the most popular confidence level used in test of hypothesis. So what are we going to do? Again, this is our sample and these are our measurements for the bottle's capacity. So the first point is to calculate the sample mean. So the sample mean is just only the summation of all these values, and we divide by the number of bottles, which is 9. So we are summing all the values and divide by n to get the average value or the mean value of our sample, which is 499.71. So after that, we calculate the test statistic, which is Z0. We have the difference between, this is the sample mean, this is the hypothesized, which is 500 milliliter, which is the population mean to be hypothesized. We have the sigma, as sigma square is 4, so sigma will be 2, which is the population standard deviation. We have number of elements in a sample, which is 9, so square root of n is equal to 3. So now Z0 will equal to minus 0.435. Notice that we have also the two-sided test, so that for the alternative hypothesis, we have a mu is not equal to 500. Now let's do our test. We have this normal distribution. So we have chosen the 95% confidence level. So this will be the area under the curve to be 95%. So because we have two-sided test, we have divided the 5% into two sides. In the right we have 2.5%, also to the left we have 2.5%, because we have two-sided test. So now we have also the test statistic Z0 minus 0.435. So this is the normal distribution, which is the standard normal distribution with mean 0 and sigma square equal 1. Now from the normal or the standard normal distribution table, we should look for this value, which has an area to the left to be 2.5% or area to the right of this value to be 0.975. 0.975 is the summation with 0.95 and 0.025. So the area to the left will be 2.5% and the area to the right will be 97.5%. From the standard normal distribution table, we will calculate this value. So this is called the lower limit, or Z1 minus alpha over 2. So alpha is 0.5 or 0.05 and alpha over 2 will be 2.5%. So this value will be, from the tables, will be minus 1.95. Also the same for the right side. From the tables, we will calculate the Z upper or Z alpha over 2. Now alpha over 2 will be 2.5. So in fact this Z alpha over 2 means the value of Z which have area under the curve to the right of this value, the area under the curve will be 2.5. So the area under the curve to the right of ZU or Z alpha over 2 will be 2.5%, which is 1.96 from the tables. So now Z0 is in fact inside this value. We have this is minus 1.96. We have this value 1.96. If you look for the Z0, in fact Z0 lies inside the green area. So the green area is the acceptance area. If the Z0 falls in the green area, so we will fail to reject H0 or fail to reject the null. If Z0 falls in the other sides or the rejection region, either to the left here or to the right, we will reject the null. But here in our case, we have Z0 to fall inside the acceptance region. So since Z0 is between the upper limit and lower limit, we conclude that we fail to reject H0. What does it mean to fail to reject H0? So this means the bottle capacity is statistically still at 500 milliliter. So our null hypothesis is accepted, and from statistics the bottle's capacity is still at 500. So no, we don't need any other action to be done, or the mean value of our population of bottles have been or stayed the same at 500 and has not changed to any other values, neither to the upper values or lower values.